Okay, let's talk about my favorite beacon, the DNS beacon. First, we're going to talk about how the DNS beacon beacons, meaning how it calls home to check if there's a task available. The DNS beacon runs on a compromised system, and it makes an A record request to a domain that you, the attacker, are authoritative for. Okay? So it might make a request for 1234.profiles.losenolove.com. It's going to forward that request to the DNS server in its network configuration. That DNS server is going to ask, is this host in my cache? Yes or no? Okay? If that request is not in its cache, that server's got a choice to make. It can forward the request onto another server, and that server can go through the process of checking if it's in its cache or not. And we call that a recursive query because the DNS server is forwarding it to somebody else to deal with. Or the DNS server might opt for what's called an iterative strategy. Here's how an iterative query works to resolve the IP address of 1234.profiles.losenolove.com. First, the DNS server goes up to one of the root name servers and says, hey, root name servers, can you tell me an answer for this host, 1234.profiles.losenolove.com? And the root server is going to say, I don't know, but here's a name server that is authoritative for .com. Why don't you go ask it? DNS server says, okay, cool. It then goes to the .com's authoritative name server and says, hey, .com, I have this host. What do you think? What's its IP address? And the name server authoritative for .com is going to say, I don't know. Why don't you go ask the name server that is authoritative for losenolove.com? And the DNS server is going to say, okay, sure. So now it goes to the name server that is authoritative for losenolove.com, which in my case, because I own that domain, it's GoDaddy. So the DNS server is going to go to GoDaddy server and say, hey, GoDaddy, what do you think of this host? What's the answer? And GoDaddy's name server is going to be like, I don't know. You're trying to look up 1234.profiles.losenolove.com? Why don't you go ask the name server that is authoritative for that subdomain? And then the DNS server says, okay, I'm going to go ask that name server. So then it gets to our Cobalt Strike team server that is running a DNS server. And our Cobalt Strike team server says, hey, 1234.profiles.losenolove.com. I love the request. And Cobalt Strike is going to check if there's a task or something else it wants that DNS beacon to do, and it's going to signal what that DNS beacon should do next in that 4-byte response to that A record request. So that's how DNS beaconing works. Now, let's get a little bit more specific. I did not design the DNS beacon in Cobalt Strike to provide a DNS communication capability. Between us, I think DNS communication is noisy, and if a hunt team is looking for it, they are going to find it, okay? That said, I do think DNS beaconing has a lot of utility. I designed DNS beacon back in 2012, mind you. I designed DNS beacon to use DNS as an out-of-band signaling mechanism to reduce how often Cobalt Strike's DNS beacon payload has to connect directly to our team server. That's it. So here's the original model of how the DNS beacon works. First, you get the DNS beacon on a target, okay? The DNS beacon payload stager downloads the DNS beacon using an HTTP GET request, okay? Once the DNS beacon is in memory, it starts beaconing over DNS to check if tasks are available. Only when there's a task available, as signaled by the DNS response, does the DNS beacon actually connect back to us, the attacker, and download its tasks. And originally, this always happened with an HTTP GET. The DNS beacon today can stage two different ways, okay? you can stage the DNS beacon over HTTP. And that's the Windows Beacon DNS reverse HTTP payload, okay? In many parts of Cobalt Strike's workflow, you do have the option to use the DNS text record stager. But if you always want to use the DNS text record stager to download the DNS beacon, you're going to use the Windows Beacon DNS reverse DNS text payload. The DNS text record stager uses text records to download the Cobalt Strike DNS beacon. Bear in mind that this process is noisy and it takes over 1,000 requests to download beacon over DNS. Also, keep in mind that these two stagers deliver the exact same DNS beacon payload. Now, when you configure the DNS beacon, Windows Beacon DNS reverse HTTP, I want you to keep a couple of things in mind. That new listener dialog, okay? In that dialog, you are configuring the payload stager, okay? So in this case, Windows Beacon DNS reverse HTTP, it stages over an HTTP GET. So by putting in malwarec2.losenolove.com and port 80, we're telling Cobalt Strike, stand up a web server on port 80 to stage that payload and handle any HTTP communication with the target, okay? Or from the target, I should say. When you press save, you are then configuring the DNS beacon stage and telling it which domains it should beacon back to. It is very important that the Cobalt Strike team server is authoritative for these domains by you creating NS records for these domains that point to your team server. We'll talk about that in a moment. When you stand up the DNS beacon with Windows Beacon DNS reverse HTTP, many parts of Cobalt Strike's workflow will present the same listener twice. They'll present the listener name by itself, that's the HTTP stager, or the listener name parenthesis DNS parenthesis, that is the TXT record stager. Anywhere in the beacon console where you specify a listener, you may also specify parenthesis DNS parenthesis to force Cobalt Strike to use the text record stager instead of the HTTP stager. Now, all that DNS text record stager versus HTTP stager, it's a little bit confusing, okay? I know that because I support this product and I get a lot of questions, okay? There are many times where you probably just want to use the text record stager. You don't want to bother with the HTTP stager. I get it. For those situations, I created the Windows Beacon DNS reverse DNS text option in Cobalt Strike, okay? This is your option to tell Cobalt Strike to always stage your DNS beacon over DNS. A couple of things to note because there is a little bit of potential confusion here. When you configure the listener, the TXT record stager does not care what you put in for the host, okay? It's just going to ignore that value because normally that host value is there to configure the HTTP stager. It does use the port though, and it uses the port to designate which port the web server should bind to for any HTTP GET or POST request that the DNS beacon might make depending on its data channel. More on that in a moment. When you press save, you get to configure the payload stage as usual. Now the DNS text record stager will randomly select one of those domains from the payload stage configuration to download the DNS beacon over DNS. Now, let's continue our story about the DNS beacon. It was built to reduce how often the compromised target would need to connect back to you, the attacker, directly. Over time, I quickly saw a problem in this scheme. And that problem is what I call the child in the well scenario. I would get beacons on target, they would respond for a while, and then I would run into a situation where the beacon would call home over DNS, okay? So I would see it beacon, but it could not connect to me over HTTP to download its tasks. I call that the child in the well because the beacon is out there calling back to me saying, I'm here, help me, and I, the concerned Shell Sherpa, cannot talk to or control my beacon. And my friends, that is a very, very sad situation to be in. So the child in the well scenario prompted the mode command in beacon. Mode is a command that allows you to change the data channel in beacon on the fly while it's deployed. You can do mode HTTP to use HTTP GET as a data channel and post to send output. You can do mode DNS to change the data channel to DNS A records, and beacon will download its tasks 4 bytes at a time by making multiple requests to the domain that you, the attacker, are authoritative for. Or you can do mode DNS text to download your tasks over DNS TXT records. Both the DNS and DNS text record data channel will send data back by embedding it inside of a very long hostname request. Okay? Couple of things to note is that Malleable C2 gives you some options to restrict the lengths of these different DNS queries in case the length of the DNS query is something that's getting your DNS beacon caught. Okay? So I created the mode command to give you the ability to recover a beacon if you encounter a child in the well scenario. The data channel is signaled in the 4-byte response beacon gives back to the A record request for its beacon step. Now, what I want to point out is with the mode command and the DNS text record stager, you can use the DNS beacon to control a system entirely over DNS without it ever once talking directly to you. First, get the payload to the target, however you choose to do it. Use the text record stager to download the DNS beacon, okay? And that will use DNS text record request to get it. Once the beacon starts beaconing back, use the mode command to change the data channel to DNS text or DNS. Now, any tasks you issue, beacon will download those tasks over DNS or DNS text records. Give beacon a task and it will check in for the first time. It'll populate the beacon's metadata and you can rock and roll from there. Now you can imagine there's a lot of setup involved with the DNS beacon. It's not too bad, but it does require paying attention to the documentation or this video. So first things first, you're going to need a domain. You can go buy one for 10 bucks at GoDaddy.com. And what you're going to want to do is edit the zone file for that domain you control. Okay? First, you're going to want to create an A record that points to your Cobalt Strike system. Okay? Next, you're going to want to create NS records that delegate subdomains or entire domains to the fully qualified domain name of your Cobalt Strike team server system. Okay? Here's what that looks like. Here, I have an A record, malwarec2.losenolove.com, that points to a previous Cobalt Strike team server I once had. Okay? Next, I decided to delegate freepix.losenolove.com, game.losenolove.com, and profiles.losenolove.com to malwarec2.losenolove.com. And so I did that by creating NS records, name server records. Once you press save and update your zone file, you should be in a position to receive callbacks from the DNS beacon. Here we are in Kali Linux. I'm going to show you how to create a listener for Cobalt Strike's DNS beacon. For this demo, we're going to work through the EC2 team server malwarec2.losenolove.com. Let's go to Cobalt Strike, Listeners, press Add, and let's create a listener for Windows Beacon DNS Reverse HTTP. Let's give it a name like EC2, malwarec2, DNS beacon. And here we're configuring how this payload stages over HTTP, okay? So we could put a redirector in right here, But we'll just do malwarec2.losenolove.com for now and port 80. Looks good to me. Let's press save. Now let's provide a list of domains that we've delegated to our Cobalt Strike DNS server. Let's do profiles.losenolove.com, freepix.losenolove.com, and game.losenolove.com. Those look good to me. Profiles, freepix, and game. Let's press OK. And we now have a DNS beacon stood up on this particular team server. Now let's go through some steps to verify that this infrastructure is working. Let's go to a terminal and let's use NSLOOKUP to query the Cobalt Strike team server directly and make sure that the team server is responding to DNS requests. And we'll just do a query for this is a test. And you can see we get back an answer 0000. This is Cobalt Strike's default response from its DNS server. A malleable C2 profile may be able to change this value in the future, but for now, expect 0000. Now, let's go ahead and get out of that. And let's verify that our delegated domains are working as expected. Let's do this is a test.profiles.losenolove.com. And we get 0000. It's good. Game.losenolove.com. That's good. And freepix.losenolove.com. Very good. Now, if you want to see the path a query takes when an iterative request is made, you can do dig plus trace, okay? And we'll do this is a test.profiles.losenolove.com. And here you can see that this is a test.profiles.losenolove.com is ultimately answered by malwarec2.losenolove.com. Here's GoDaddy's name server stating where who is authoritative for profiles.losenolove.com. Okay. And you can see you're able to actually go through the whole iterative request process, including my local DNS resolver, to see the path that query takes. If you run into any issues with DNS beaconing, this can be a great troubleshooting tool. Okay, now we should have some degree of confidence that the DNS beacon is set up properly, the records are correct. Now let's go ahead and hook a target with the DNS beacon. We'll go to attacks, web drive-by, PowerShell web delivery. And here we can see the listeners from all the servers we're connected to. DNS beacon by itself, this one stages over HTTP, and parenthesis DNS parenthesis stages over DNS text records. Let's use that. And let's make PowerShell web delivery. Go to malwarec2.losenolove.com. This could be a redirector, but it's not. Let's hit launch. We now have a PowerShell one-liner to deliver our beacon that stages over DNS. Let's go ahead and hook a target. Right-click run, paste in that line, and now our payload is downloading itself, or excuse me, our payload stager is downloading the DNS beacon with DNS text records. It's 1,000 requests, roughly, and over internet infrastructure, such as we're using here, you can expect the staging process to take about 1 minute, okay? So we'll see our payload come in pretty soon, but just give it a few seconds, or I guess a few tens of seconds. And there we are. Our payload just beaconed in for the first time. Because we have not told the payload to communicate with us, okay, we have not given it a task, it is actually not actually sent any data. It's only beaconing at this point. So that's our opportunity to configure how this payload should beacon, or how it should communicate with us. So if we go right-click, interact, we can change the data channel to mode DNS text and give it a task like check-in. Okay? And check-in is basically an empty task that means do nothing, but it does force the beacon to check in next time it beacons back. So we should see this payload come home in about 10 seconds. And when it does, you will see all this metadata populate. And there we go. Our beacon just checked in and it sent metadata to us. And now we know something about this session. So that's how you set up the DNS beacon and how you configure the data channel and get the DNS beacon to check in.